All right, so hey everyone, welcome to this talk on btrfs, 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 however you want to pronounce it. Has anyone ever actually heard of this? That's cheating. You guys have heard
Well, I've
of it.
never used
Linux
it.
magazine.
It comes with the CentOS. No, I don't know what is this.
Okay. So, first off, who am I? Puyo. I'm an engineer. I have a couple of funny hats as degrees. I have electrical engineering and software engineering. I have a couple of fancy pieces of paper. Certified ethical hacker. That's a cool title. Certified data recovery expert, so I know a lot about hard drives. This year's AV director, as well as last year, and I've been doing videos for the past couple months. So first off, what is btrfs? It's a newer Linux-based file system, and it is awesome. Any questions? Seriously though, why do we need a new file system? Referring to the XKCD, there are 14 competing standards, and soon there are 15 competing standards. Why do we need a new file system? Really, there's 3 common file systems in use: Linux, ext4, Windows, NTFS, and Mac, HFS+, which is now slowly being upgraded to APFS. So more about all of these in a second. So Linux, ext4. ext4 came out in October 2006. It was basically ext3 with some optimizations and some trim changes. ext3, November 2001, which is ext2++. ext2, January 1993. It's 2017, so we're still using these core this core file system that dates back to 1993. Windows is not much better. NTFS replaced FAT32 on July 1993, and it came with Windows NT 3.1, Windows 2000, and Windows XP. HFS+, any old Mac users here? 1, awesome. Do you remember ever seeing this? This is actually a very hard image to find, and only one person, like one server, actually had that available. So if you look up, if you've tried to look for this, where have all my files gone? It's always that one thing. So HFS+ goes back to 1998. HFS, 1985. HFS+ actually uses B-star trees, which is slightly different. If you actually upgraded your operating system from, like, I think was it Mac OS 8 to 8.1 or 7, something like that, you would actually open up your file system and it would say, you'd have this little image that says, where have all my files gone? And you open it up and it says, this hard disk is formatted with a Mac OS extended format. Your files and information are still on the hard disk, but you cannot access them with the version of software you're using. How can you access these files? To access these files, you must mount this hard disk on a computer that's Mac OS 8.1 or later installed. Oh, and by the way, here's where you can go buy it.
How convenient.
Yeah.
Great salesmanship.
And that's Apple. So ext, just reviewing all this. ext 2, 3, and 4, going back to 1993. HFS+, 1985. NTFS, 1993. XFAT, which is a product of Microsoft, 2006. Oh, that's kind of new. APFS, this year. And that was actually something really interesting I looked into. Only on High Sierra, the latest version of Apple OSs, is it actually bootable. So there's also ZFS going back to 2005 and btrfs going back to 2009.
Riser.
There is Riser. Yeah. So
It was right.
Yeah.
this guy is Theodore So, and I'm probably butchering his last name. He's actually the principal author, developer of the ext 3 and 4 file systems. And he flat out said that btrfs is a better direction because it offers improvements in scalability, reliability, and ease of management. So even though he was a primary developer of ext4, he's like, So I've been saying all this. btrfs, 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 they're all correct. Who all uses this stuff? Facebook, TripAdvisor, OpenSUSE, Debian, and Ubuntu have this as an option whenever you install. Rockstore is a FreeNAS-like NAS operating system that has btrfs actually baked into it, as opposed to FreeNAS's ZFS. Netgear's ReadyNAS use those. Red Hat Red Hat Enterprise Linux used to actually offer btrfs, sorry, as an option, but then they did away with it recently. And they opted to hold out for something called Stratus. So what's Stratus? It's described on Fedora's wiki as a local storage system akin to btrfs, ZFS, and LVM. Its goal is to enable easier setup and management of disks and SSDs, as well as enabling the use of advanced storage features, blah, 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 blah. Provisioning, snapshots, new file system, woo. Their roadmap. The first half of 2018, they hope to have version 1. And they hope to support snapshot management, file system maintenance, and more. 2, no idea whenever that's coming. They plan to deal with RAID then. Write-through caching quotas. Version 3, they hope for rough ZFS parity. It's also developed and Rust in Python. A file system developed in Python.
Interesting. Just trying to.
High performance? Secure?
I don't know. I was reading through, I was like, oh, okay, let's read about, it's developed in Python? What? Oh, weird, okay. So going back to btrfs, who uses it? Chris Mason is one of the primary developers of btrfs. He actually currently works for Facebook. And he said, with Facebook, one of the reasons why they like it is it offers data cyclic redundancy checks and metadata CRCs. And it actually is able to detect problems in the hardware, such as silent data corruption. Who's all writing this stuff? Oracle actually started developing it whenever Chris Mason was at Oracle. He then moved to Facebook and is still the primary developer. It is open source, so everyone can contribute to it. Facebook uses it, Fujitsu's contributed to it, Intel, the Linux Foundation, Netgear, SUSE, like I said, Chris Mason. So all these ask the question, why not ZFS? So ZFS is open sourced, but it's not Linux friendly open source. So it's actually CDDL versus GPL. ZFS is also crazy intensive in RAM. 8 gigs of RAM is like the bare minimum. 16 gigs of RAM, 32 gigs, yeah, okay, yeah, you can actually start doing that. So Oracle, remember, Oracle actually developed btrfs. They actually started developing it before the Oracle Sun acquisition. So some crazy cool features about btrfs now. We're going to talk about that. Is a COW, a copy on write file system. So it's a little different than what you're normally used to. Whenever you write one file and just overwrite it, it'll actually, with your traditional NTFS, FAT32, those kind of file systems. Copy on write means every time you make a change, it creates a new file. It creates a new node, or a new, what do I call it? Kind of like an inode, but different. So, it also supports file system level compression. And there's 3. Actually, originally there was only 2, and then after I wrote and developed these slides, Facebook added a 3rd. So there's zlib, LZO, and ZSTD. So I actually have some comparisons on file system reads versus overall data usage. So other features, it actually supports subvolumes, supports quotas, and snapshots, which really are just subvolumes with some data in it originally. And you can also make subvolumes read-only. Whoever has tried to remove a stubborn file, say, all right, rm this. Nope, you can't do that. All right. Sudo rm this. It usually blows it away, right? Unless it's very special. Even with a read-only snapshot, root cannot just rm-rf a volume. So, like I was saying, you see at the top here, no file system compression, compression in terms of megabytes a second, decompression speed on the right. LZO versus zlib versus zstd. Remember, zstd was actually introduced by Facebook, which was actually written for them by the primary developer of btrfs. So even just zstd1, you can see 260 megabytes a second in terms of compression and 383 megabits a second for decompression at a very, very respectable ratio. Other cool features. You can actually send file system chunks. This is a little different, it's kind of hard to describe. So say you have one file system here, and another file system here. You can actually send the whole file system in a snapshot to this other file system. Okay, cool. Now you have these two. If this was ext, you delete a file here, or you rename a major Windows 7 ISO or something over here, use rsync. What happens? It sends the whole thing again. Delete a file, and then it actually, you change the name. Deletes all the files over here, and re-uploads all of them. Kind of sucky. btrfs, the subvolume send, will actually send the changes that were made on the file system over here. So rather than send 20 gigabytes of data, it'll only send a couple megabytes, because all it's doing is just sending the changes in the metadata. Changes over here, done. It also does offline conversion from ext3 and ext4 into btrfs. And it has a couple different storage modes. In single, double, RAID 0, or RAID 0 1 like, RAID 1 like, RAID 5, 6, and 10 like. And it can convert all these RAIDs on the fly without unmounting the file system. You have a live file system. Thank you. It's a live file system with changes and reading on it at the same time. And you say, hey, I got another disk. Pop it in. Okay, well, I want to RAID 1 them. Okay, it's doing it. And you're still reading and writing. That's so cool! So a couple features not yet implemented. There's file encryption, which they currently recommend using dencrypt with btrfs on top of it, and deduplication, which is a work in progress. So RAID, how many people are here familiar, or not, how many people are not familiar with RAID? Everyone has a great grasp on RAID.
Not great.
Hmm?
Not great.
Okay, but you understand, it's a redundant array of inexpensive or independent disks, multiple disks acting as one. Different levels, different features, different safeties. RAID 0 is not safe at all. RAID 10 is pretty safe. And then hardware and software. You have to go back to the water cooler reference. With RAID 0, 2 water coolers. RAID 1 side by side. 5, you got 3 acting as 1. RAID 0, it's actually RAID 10. Again. So, to kind of explain a little bit better than how I can, how btrfs handles RAID or RAID-like systems, this was one that really just like, oh, okay. And so I wanted to give it credit. So traditional RAID 0, as it says. Oh, it just says, and they're talking about raiding their dressers for their underpants, right? So traditional RAID 0. Hey, I'll just stripe across all the disks. Traditional RAID. Boring. Mere identical drives. Yay. Woo. Very, very boring. And each of these drives have to be 2 terabytes each.
You get double the read on
You do. So traditional RAID 5. Pros, storage efficiency. Cons, everything else. Slower to read, slower to write, and you get 1 drive tolerance. Again, 2 terabyte, 2 terabyte, 2 terabyte. traditional. Come on. There it goes. Traditional RAID 6. Guaranteed 2-drive failure survive. Cons, again, everything else, where you have 4 or more drives acting as n-2. Again, very boring. You have 2 cross of 2 terabyte drives. RAID 10, RAID plus RAID is more RAID. So btrfs RAID 1, you have a bunch of drives. RAID 4, or 4 terabyte, 3 terabyte, and 2 terabyte. So as you see, it's not exactly RAID, it's RAID-like, where RAID 1, the big thing is you at least have one other copy of it. So you can kind of visualize, hey, okay, that's kind of cool. But what happens whenever you get another 2 terabyte drive? You plug it in, you add it to there, and it actually will start filling up this other drive in line with all the others.
So if you lose that 2 terabyte drive, you lose the whole file system?
If you lose a 2 terabyte,
Well, in that example.
You have the-
in this example, there's a lot, well, if like you lost, like this one, you mean?
Well, frankly, what I'm saying is any of it, it looks like it's not literally copying to every drive.
It is,
Then you have-
every file that is written, every block that is written, is at least written on one other drive. So you could have that 4 terabyte drive go away, and you still have any one drive failure redundancy.
In a traditional RAID 1, you could have 4 drives. They would just all have the same data.
Right,
So you could lose 3 drives. you lose,
right. But the big thing is, in a traditional RAID 1, all right, and now I have another drive. Can I just plug it in and bam, everything's all back to it?
You'd have to reboot, probably.
Exactly, you would have to
And then
re-silver,
balance.
yeah, exactly.
How robust is that file, that file system level compression and recovery problems? I remember back, I guess it was early 90s, that there was a fad for a time of on-the-fly compression. But if you had a error glitch or software problem, you'd lose you basically lost the entire contents of the file system.
So how btrfs does the thing, with the copy on write structure, every time it creates a new, or modifies a file, it creates a tree, or it creates a branch of the tree. If you have a power failure, if your entire file system goes kaput, you can actually go back, and there are multiple copies of all these metadata and all these trees that you can actually go back then and say, all right, I can look back at this write from this tree. Okay, well, actually, I see another generation down here. I see another generation. I see a later generation. And so you can actually recover multiple generations from a file system.
So is it a
version
version
file system?
where it retains all versions of every edit if you tell it to until it runs out of space and starts deleting all stuff?
Yes.
Can you repeat what he said?
It is kind of like a versioning file system where every time you write a file, it will create that version in the overall space, and then whenever you run out of space, it will actually start overwriting the unread or the unused areas. So storage levels. Single, there's a couple different storage levels that you can tell it to go into. Single, where it's just one copy of data. Duplicate, just 2 copies of the same data, but it can just be on the same drive. RAID 1, again, is just 2 copies of data across different drives. RAID 0, 1 copy across different drives. RAID 10, where so on and so forth. RAID 5, which is 2 chunks of data, 1 chunk of parity, just written across and distributed. Same for RAID 6. So, as you can see, traditional RAID 1 is not btrfs RAID 1. You can also have, as I've shown, arbitrary sizes of hard drives. That is so cool! MDADM will say, oh, what's your lowest common denominator? Okay, well, that's what you got. Sorry. So if you go to carfax.org.uk/btrfs-usage, I know it's like, what? Carfax? They actually have, show me the Carfax. Yeah, they actually have a calculator on there. You can say, I want to add 5 disks with these arrangements and this kind of data structure of RAID 5, and it will actually kind of visually show you where all the data lies at.
Did I read it right? I don't have to partition your drive anymore?
Yes, you do not.
Yes, it is no, or no, it is yes.
Are there other people in this house? You do not need to partition your drives. You can, btrfs will actually use the entire,
Whole block device.
the whole block, yes. The problem whenever you are installing though, is you typically have the first 512 bytes be your master boot, the first 446 bytes be your master boot record, followed by the partitioning information. So your primary boot device probably would need to be partitioned. But if you can have like dev SDA1, dev SDA2, SDA3, whatever. But then you just have dev SDB, SDC, SDD, and it can actually use the entire information to tie the entire space.
That makes pubbiting it a lot easier because partitioning for pub is difficult.
I highly recommend still partitioning your drives, because when the kernel boots up, it'll look at that block device and try to read partition information. It'll get a bunch of erroneous, like, doesn't make any sense, like, can't read partition data from
Freaked out a little bit.
SDA. Like, it's fine, it still boots and everything, but when you do go and lose the drive, that's frightening to see.
Yeah,
So,
yeah. So it's a good practice to still do, but you don't need to. Fun little fact, a RAID 5 in btrfs can be done with 2 drives. Yeah, it's like, huh? Where they basically said that one drive contains all the data, one drive contains all the parity. I don't know.
does the second drive have to be twice the size?
It was parent.
I mean, to me, it's like, wait, RAID 5 with 2 drives, so it's essentially a malformed RAID 1, but it works?
It's
Technically
the
functional.
opposite of the main drive. When it's a 1 on the main drive, it's a 0 on the parent drive. I'm trying to figure this out.
And if you set them on top of each other, they explode.
It's like geotech.
Anyway, yeah.
So-
Andy did it.
Another different way to think about it is say you have 2 1 terabyte drives and then 2 500 gig drives. MDADM, of course, will say, oh, 500 gigs, that's what you got. However, traditional RAID is not this kind of RAID. It is think about it that multiple smaller drives can stack together with this kind of little visualization. That the 2 terabyte drives roughly equal about a 4 terabyte. So here a RAID 5 would actually yield a 8 terabyte storage volume. So I mentioned you can swap between swap between everything. If you do the btrfs balance start mount point, it'll actually balance everything out, make everything nice and pretty, where instead of all the data being on one drive and scatter the rest on the other, like the example before, it'll actually shuffle everything out, so it's all nice and balanced.
Kind of like defragging.
Kind of like defragging, but there is also a defrag command, which is different. Yeah.
You have to defrag B trees?
Well, by nature, it's copy on write. So that's one of the major drawbacks is it is very hard drive thrashing. It's very fragmented. But to convert between different RAIDs levels, you would say, balance start -D for data, convert equals RAID 1, -M for metadata, convert RAID 1, your mount point, and it'll chug, and it'll get it done. But the other really, really cool thing is say you have an 8 terabyte RAID, old style, with using MD80 or something. All right, you put a new drive in it, the one drive fails, you put a new drive in, all right, let it go, but you only used 500 megabytes, it's brand new. What is it gonna have to do? Traditionally with MD80, it will go resilver the entire 8 terabytes.
You'll be degraded.
Even though,
You'll be degraded with those.
I'm sorry,
Your state will be degraded.
yeah. And so it just sits there, but the big thing is it'll have to read and write 8 terabytes across all your drives. So you're sitting there like, oh, come on. With btrfs, it only copies and balances out the used portions. So if you only have 500 gig used on an 8 terabyte array, it'll only copy and shuffle around 500 gigs. So I mentioned this a couple times, the metadata. So what exactly is in this metadata? So every chunk of your data, of the actual data, is checksummed and stored. And upon every time you read it back, it'll actually do a checksum again on that data and compare it with the metadata that has that checksum. So this way, if something were to happen to your data and like your hard drive is failing, it'll say, hey, this actually doesn't match this. You have a bad problem. If this were in a RAID, it'll say, whoa, this doesn't match. Let me try the other. Hey, this checksum matches. All right, I'm going to go ahead and return this. And in the meantime, I'm going to rewrite the bad sector, the bad stuff. So it'll actually do all this stuff in the background. It is so cool. So the snapshots and subvolumes. Again, it's kind of like a mounted partition, but it's not. So it's accessible like a directory, but the subvolume itself can be on a completely different disk. It can be made read-only, and even if you do, like I said, if you do the sudo rmrf, the path to the read-only snapshot, it says you do not have permissions to do this operation. So if you don't know what you're doing with btrfs, you're like, but I did this root. Why don't I have permissions? What is this, Windows? That's the Linux, yes. So, if you can actually also do a snapshot, yes, Brimstone.
You can make snapshots read only. Can you then make them read writable again? Or
Yes.
is it like a one?
Yes, you can actually through a changing of the changing a tag on the actual subvolume to say this is now read write done. Yes.
For e-discovery, have they been used to leave appears to zero?
I am not aware of any. But one of the other really stupid cool things about snapshots is it can happen in seconds. So you can snapshot a 500 gig hard drive, not a solid state. Say, all right, I want to take this, do a snapshot. Okay, cool. And you can still access it. You can still access it like it's just another mounted directory. Because all it is doing, instead of copying all the data, it is just copying all the metadata, copying all the directory structures, copying all of, and just storing all that, which is already written. And saying, oh, there it is. Now whenever you do a copy on write, it'll go around.
Do you know if any distros make snapshots every boot for like a meet restore feature?
I'm not aware of any. I'm not aware of any OSs that do it out of the gate. Was it Cent? I think Cent and no, not Cent. That's Red Hat, Fedora. But SUSE is actually one of the major supporters of btrfs, and they actually, by default, support their default file system is btrfs. But it's Linux. Do a cron job. Do it on boot. Make a new snapshot. Chris, I think it was Chris Mason or one of the other developers, he actually has scripts that run like about every hour. They just make a new snapshot. Make a new snapshot. Make a new snapshot. Oh, hey, it's full. All right, delete the oldest one. And just goes on for hours. Every hour, on the hour. Because why not?
Allows you point time recovery.
Mm-hmm. Oh, I didn't mean to delete that file. Okay, well, go back. So, and there's hardly any additional drive usage because, again, this is all written to the drive itself. It's already written. All you're doing is saying, all right, here, cap it here. And just due to the nature of the copy on write. So sending and receiving, like I had mentioned, you have the two file systems. You can say, you can actually pipe this through, it's designed to run at the standard input. So you can pipe it through SSH. You can pipe it through, the example I use here, let's say one CD ISO. You rsync it over to a backup location, you change the file name, and then it'll actually delete the cd.iso, and then we'll have to rename it to the Debian.net installation ISO. But again, with btrfs, it'll say, wait, you just changed this, okay, done. Bam, cool, offsite backups. Stupid easy. So downsides, I've been playing, this is so cool. Downsides, like I said, copy on write, fragmentation. Oh, fragmentation. There is a manual defragment, which is different than a balance. And trees can become unbalanced, so you have to rebalance occasionally. Virtual machines with a copy on write file system, terrible. So unfortunately, the best thing to do is actually disable these copy on write by using the chatter, CHATTR, plus C, which says, all right, on the file system, disable copy on write for this directory. And it can only happen on new directories. So even though you have my VirtualBox, my VMs, you say, all right, this is now non-copy on write. Okay, it'll say that, but it won't make that for the old things. So you actually have to create a new directory, say this is not copy on write, copy all the files over, and not move them, delete the old directory, rename it.
To paraphrase, you're saying that the host machine that's...
Yes, I'm sorry, this was all on the host machine.
Oh, because the VMDKs change a lot.
Exactly. So yes, the VMDKs, virtual disks, they change, they do a lot of writing just by nature.
Does that mean you lose out on like snapshot features and stuff in that directory?
I am honestly not sure. And the only time I've ever used the non-copy on write with that was inside of VMs, but then it's like, all right, well, VirtualBox has snapshot features. I mean, it has its own features built into that. Database performance, if you go to the PhreakNIC website where they benchmarks things daily, 9 times out of 10, database performance is terrible on btrfs. So don't use it for databases. Checksum up because it's doing this checksum for every single read and write. It's awesome for data integrity, but you gotta data performance it. A lot of times, if your devices get to about 95% usage, a lot of times metadata takes up space too. You can get unbalanced trees. They'll say your device is full, but you're like, I still have 10 gig. What's going on? That's another unfortunate downside. df-h. Show me what's free. Isn't exactly true. It's kind of like, what? It's just free space. But you're looking at different things. You're looking at snapshots. You're looking at compression going on. And every time that btrfs will say, this is my chunk of data. I'm going to write to it. Oh, I'm running out. Okay, check another chunk. DF will say, this much is used. But the actual internal btrfs systems will say, oh, it's actually only about this much.
Will trees become unbalanced just under normal usage? Like I understand when you add a drive, they'll become unbalanced, but just like day-to-day.
If you do major data modifications, so like if you have a ISO of a hard drive, or a DD ISO of a hard drive that's 10 terabytes on a, say a 12 terabyte array. All right, you leave that 10 terabytes, yes, it's gonna get heavily unbalanced. But if you're doing the delete a little file here, write a little file, day-to-day operations, probably not.
Is it a good idea, bad idea to just have like some cron tab that does the defrag and the rebalancing?
Not a bad idea at all. It can take a while because it is reading every single chunk of data and sort and kind of rearranging it and trying to balance it across all your drives. So it will take a long time, the more data you have. But again, these are downsides, but at the same time, you are getting checksum data integrity.
Yeah.
The other downsides, RAID 5.6. Has anyone ever heard of what's called the write hole? It was actually described earlier on. You're in a RAID, going, power outage, poof! Some of the RAID, some of the data actually was not written to the hard drive. This problem is still happening. It's still there with btrfs. To be fair, MD RAID has the exact same problem. So if you're using MD RAID, no, you're not in any different boat if you use btrfs. So the scrub operation. Oh boy. So in July 2016, there was a condition that was found that would restore bad data. What the scrub does is it will actually go through every single block of data and do its checksum and compare it to the metadata. And that's what a lot of people say needs to happen just monthly, just as a cron job. Just go through and make sure everything's good. If there's bad problems, restore it if it's in a RAID. There was a issue that it would actually, I still don't quite fully understand it, but it will actually take the metadata and say, wait a minute, this is the wrong drive, or it was look at the parity metadata and would mess that up and be due to a race condition in the actual file system, and it would restore invalid data. So your scrub operation, which is intended to verify all your data, is actually mangling your data. So that actually was that was found in July. There was a patch submitted in November. However, if you're using kernel 4.13 that was actually pushed in July 2017, that fix is actually in there. So, and if you go to kernel.org, or patchwork.kernel.org, patch blah 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 blah, they actually say RAID 0 and 1 and 10, they're considered mature. They firmly say, go forth, do great things. RAID 5.6 are still described as heavily under maintenance and development and experimental.
Does the scrub operation only apply to RAID 5 and 6? Or
No.
Also,
You can do a RAID. You can do a RAID 1, RAID 0. You can do a single drive, duplicate with duplicate data, just with a scrub operation in a single data storage configuration. It will just say you have bad data. It wouldn't be able to recover on it. It would say, oh, okay, you have bad data, and I saved it. Go me. So, conclusions about this whole thing. btrfs is stable in the single, the double, RAID 0, 1, and 10. RAID 5.6 does have some underlying bugs. So, file system compression is awesome. I actually did a talk last PhreakNIC on Diceware, and I would create a word list. If you actually did ls-lah for that one word list, it was gigabytes. I think actually it was maybe using a terabyte, but it was only using up 1 gig of my hard drive space because it's all words. It's all just ASCII data. Compresses down, crazy awesome. Snapshots, so cool. Have you ever been somewhere and say, hey, hold on, let me make a quick snapshot of my entire file system while you're using it? And then say, all right, yeah, here you go, knock yourself out. They erase the entire root directory. Oh, okay, well, my snapshot's still there. Okay, boot into recovery media, do some tricks, get it all back, you're back up and running. I've actually done that with, I was trying to install some graphic drivers on my old laptop. I said, I'm about to do something that might mangle this. Okay, do a snapshot, 2 or 3 seconds later, all right, apt install this, I know what I'm doing, yeah! 5 minutes later, go back. So I was able to boot into a USB environment, just do an rsync delete, or rsync -- delete. I think it excluded dev, proc, and sys, and temp, and just from the snapshot into the I guess the root file system. All right, did its thing, rebooted, like nothing happened. So you guys have been asking a ton of questions during this.
Sorry about that.
No, that's awesome. That's great. I've spent hours looking at this thing like, what? RAID 5 only needs 2 drives technically to operate? What? Let's see, we got 15 minutes. So hopefully we actually can.
In Windows.
I do have a
So,
question.
yeah.
I'm not plumbing electricity too. I used to run web servers that did a lot of bandwidth. I'll leave it at that. And if I did MD-admin with like a RAID 5 or RAID 0, then the CPU of that process alone would be detrimental to the web server.
Mhm.
Do you have metrics on what like btrfs is like doing that? On RAID 5? I know RAID 5 is not like
Those would happen, rebalance would happen in a single thread, right?
yeah, well, they're both doing math to figure out what to do.
Right. So the btrfs calculations, yes, they are done on the CPU. There is a bit of a CPU hit on that. However, again, I mean, this laptop is 2.5 gigahertz. What was your speed on that?
This was a decade ago.
Right, decade, you're talking megahertz. So it's like, oh, okay, well, you know.
Well, we'd be talking gigahertz, but it's
Oh.
not many.
That's
It's not
true.
2 of them. Little tiny.
So I'm gonna try to be
I guess we had 2. They just weren't,
Multi-core.
right. So
I think it would be ideal if the rebalancing and the other operations were able to happen in multiple threads, so that would address that particular problem, right? We have many cores in our CPUs, it's new.
Yeah, maybe that would help a lot. Yeah, it's pretty much.
and then the other thing is,
It's true.
Then again, if you're running a web server, you probably got.
What's the problem? You just ran Linux on your laptop.
well, so prior to this, I was like, all right, I need to try to figure this out. I need to get a demo ready. I had VirtualBox ready to go. And then I created I took like actually a USB device, plugged it in, said, all right, let it do its thing. Great, cool. The problem was I didn't let it fully balance, and then I deleted the subvolume from inside of my thing. What I thought I was doing was saying, all right, this is my subvolume. I'm going to make a RAID 1 of this subvolume. What I was actually doing was trying to make a RAID 1 from my underlying file system, which was 500 gigs, to this 880 gigabyte external hard drive. So it's like, oh, this is taking so long. Well, all right, let's blow it away. What I didn't realize, doing that heavily mangled it. And so until I came in here and plugged into HDMI, like, why can't I get video going? Let me try the old Windows method of rebooting, and I can't boot. So.
So you did this back
Second thing down.
Windows?
Sorry?
Yeah.
When you got 5 minutes, you make do with what you got.
Exactly.
All right, so here is 80 gigs, sure.
You gotta plug your ISO in on the top there.
Yep, there you go. Yep, downloads, because I'm going off System Rescue CD.
Mario Web.
Are you going to install btrfs?
So, I like to do a lot of stuff with this. My choice rescue system is System Rescue CD, which has btrfs built into it.
Yeah, but it's not mounted with CD.
It's all over. It's just mounted ISO, yeah. All right. So. All right, so we see we have SDA, SDB, 10 gig, 80 gig. All right. So we say btrfs, well, following brimstones. New.
It doesn't care what the label is.
No. Actually, it'll probably blow away on, so make directory, btrfs, sdb1, oh, not make directory, make file system. Durr. All right, so now I have an 80 gig file system. You say you have data is in, I don't have a mouse. Data is in a single, metadata is in a duplicate, system data is in a duplicate. It doesn't recognize it as an SSD. Cool. So now we say in make directory, this is my mount point. Mount -o, compress, dev sdb1. This is my mount point. Cool. Dev 0 f equals your file name none. Block size a 4K, count equals doing its thing. Okay. So 273 megabytes. Now I mounted this with file system compression. So do btrfs, file system usage, root, this is my file system, or this is my mount point. Used 6.32 megabits. Six megabytes compressed, or 273 value, granted, it's nothing there, compressed down to 6 megabytes. That's so cool!
You need the ISO over.
Hmm?
You need the ISO over, like SR0 and whatever that goes.
So other cool, neat little thing about with a file system built into it, it'll actually start compressing the first little bit. If it's already a compressed image, or if it's a binary or something, where it's not very compressible, it'll say, this really isn't worth it, and kind of blow it away. But it's Linux, so you can say, compress always, and do it. But I was going to show you, so we say, nice pretty tab completes. I'm going to say btrfs device add dev sda 1 to this.
This packet count.
Bam, and just like that, usage. We see here at the bottom, unallocated, 10 gigabytes of SDA1 and and 76 gigabytes on unallocated, which is, again, btrfs will say, all right, this is all you have available. I'm going to take this little chunk, which is what you see up top where it says data single size is 1 gigabyte. It's already claimed 1 gigabyte, but it's only using 9 megabytes of it. So then, this data.
When you did that, it did rate 0 by default, basically?
With this, it actually does a single. So you can actually think of it as a just a bunch of disks. So it's not quite rate, it's not rate 0, but it's that example where it's like, all right, we have this, and just fill it up and kind of balance things out a little bit. But let's see, it's what? File system balance start deconvert RAID 10. No, can't do that. RAID 1 m convert equals RAID 1 Done. I just converted on the fly while the file system was mounted on on these virtual drives from a single storage to now you see data, RAID 1, size 2 gigabytes, used 9 megabytes. So,
free up anything off of STB?
it did not free anything up because with RAID 1, you just want everything on one drive to be written to at least one other drive.
I was there with you.
You can go to RAID 0.
Is there any reason why you would
Yeah,
want to
try
have
it.
metadata not the same RAID level as your data? I saw single and double earlier.
Single,
Uh-oh.
Oh, no.
okay, I think I just lost a projector. Or maybe it's
That's
not.
not-
That was.
That's not unplugged.
I think you just reformatted the projector.
It's okay, it just snapped up.
It just.
Well,
There's a button on it for Snapchat.
All right, best laid plans. I think this is a sign that says that this talk is just about over. But before I hit the program, hit enter, yes, it just hits. You can say convert the data to a RAID 0, convert it to a RAID 1. You can have your metadata in a duplicate format, which means it's stored at least one other place. It could be on the same hard drive, it could be somewhere else. You could store the metadata in RAID 1. You can store the metadata in RAID 10 if you want. Well, the data itself is only stored in just single format. So it's kind of a good principle, though, to if your data is RAID 1, you want your metadata to be RAID 1. But with a single disk setup, a lot of times your data will be in single and your trees will be in a duplicate. Just that way, if something were to happen to your file system or your hard drive, or you get a bad sector here that affects the B trees, B trees, you at least have a duplicate of all your metadata that you can recover from. So, on that note, any other questions? Nope. All right. Thank you all very much.